Hello and welcome to the Tulare Networks webinar, How to Improve Application Performance and Continuity with an SD-WAN. My name is Neil Abogado. I'm a Director of Product Marketing at Tulare. And joining me today as your host is Alex Radcliffe, our Chief Solution Architect from Tulare. Hey Alex, how are you?
Hi Neil, hi everyone.
And we also have Joel Hampton, a Senior Network Engineer from Bremer Bank. Welcome, Joel.
Hello everyone.
What we're going to do to kick off is we'll just give you a preview of our agenda. So we got a pretty straightforward 4 topics that we're going to go through and discuss. We're going to kick it off with a presentation that goes over basically some of the challenges we're hearing from customers regarding the WAN and how an SD-WAN can come in and help address those, and in particular, maintaining application performance and uptime. We're then going to go into a demonstration that Alex will take care of as a part of to give you some examples of the technologies that we're going to discuss in part 1, actually have those in play in action so you can see them at work. And then we'll have Joel come through and walk you through a case study that will discuss his decision or the decision of his company and how they went through from basically evaluating, piloting, and deploying and working with a production SD-WAN deployment. And then we're going to wrap with a closing slide, and then we'll handle Q&A. Now, for the question and answer part of the webinar, we'd like for you to submit your questions in on the side panel. So you should see a tab there for you. And what we'll do is we'll collect those and we'll answer as many as we can in the Q&A session. So with that, we're going to go into and start discussing and going through some of the presentation. Now, what I'm going to do is just briefly, I know many of you may not know who Tulare is, or we're a relatively new company name to you. So I just want to spend one brief moment here explaining a little bit about who we are. So we are a company that's been, well, we're established in 2007. We've always been focusing on trying to build basically a better WAN. So we've been focused on WAN, trying to build performance and availability solutions for a very long time. So this predates even SD-WAN being a term or implemented. And that's part of our history. We've got a pretty broad portfolio. We actually started shipping product in 2008. We're up to our 5th generation of software, and multiple generations of hardware have gone through, and we've been able to vet that with a lot of customer and production deployment experience. And speaking of customers, we highlight here that we've got actually hundreds of customers and thousands of nodes deployed basically worldwide. And we've actually been a pretty growing company. And you would expect right now with the amount of interest that we see, including you folks joining us here on the webinar in SD-WAN, we expect that this is going to be another exciting year for us as well. Now with that, I'm going to start going into and talking a little more about what we're hearing from a couple of different sources. So as I mentioned, we've got a lot of customers that we talk to, and they share with us some purview on what they're seeing and what they're experiencing, and then we also talk to some of the analysts. And so we've got some data points here that give you a little bit of a view on what we're hearing as far as some of the trends overall. The first one is in relationship to the types of traffic that are being handled over the, overall, all the networks, and in particular across the WAN. So we're starting to hear of, an increased interest and usage of not just traditional bulk traffic, so things like email and browsing of the internet, things along those lines, but the continuation of voice over IP coming in and being leveraged as a part of the overall infrastructure, and then also VDI and video as emerging traffic types, if you will, or application types that customers are pursuing. Now, this next bullet point is one that comes from Gartner, and they highlight the fact that for most enterprises, they're seeing the amount of traffic that they have to handle over their infrastructure overall, all their networks, including in the data center and across the WAN, doubles roughly every 3 years. The next point is, while there's a lot more traffic coming and growth, most of the budgets, and this is a data point that comes from the Merites, and they did a study of a couple of hundred customers when they do an annual survey, and they found that 60% of WAN budgets are actually flat to down. And then the last point here is the standard one, which is you're always being requested, especially if you're in IT, if you have anything to do with the WAN or the network, you need to make sure that there's a quality of experience. And this is usually looked at, quite frankly, most of the applications is where the focus is at for this quality of experience. So is my application fast? Is it reliable? And does it meet the performance expectations? But what you have here and what we're hearing from a lot of people is the fact that these are very difficult constraints. I've got strong growth. I've got a flat to down budget, but I'm also being asked to maintain, if not improve, on the quality of the application experience that my clients are going to require or need. So we say that there's a new approach to your WAN that's required in order to actually go through and address these needs. So let's talk a little bit about what are some of the components and how this works. And I'm going to go through and highlight a couple of key things that you should consider as a part of this discussion. Now, the first thing is, what is the biggest concern from a network perspective that really can impact the applications? Now, it's going to be things such as loss, delay, and jitter. So depending on the type of application you have, things like voice over IP are very sensitive to delay, as an example. And loss, well, if you have enough loss, almost any type of traffic is going to be impacted by that. But, some things have retransmission, and they are able to tolerate maybe some delay in things being retransmitted, and that's acceptable. In some cases, it's not. But at any rate, you want to track these metrics as a given in order to identify how well your WAN is performing in order, once again, to maintain your application SLAs. And then the other metric we're going to talk about is the one you see there in the blue box, which is basically if there is an issue, the mean time to resolution, repair, is usually going to comprise of two very basic things. It's going to be the time to identify there's a problem and the time to recover. So what we're going to discuss here as we go through and build out this architecture is you really want to make sure that you can maximize and optimize your tracking of what the concerns are and minimize, obviously, the time so that you can recover as quickly as possible to maintain your SLAs. Now, how are you going to do that? So the first thing is we're going to talk about the architecture. So we have, it's an SD-WAN, so it's software defined. So the concept of a controller is usually going to be expected to be a part of this, and it is. So we have a controller mechanism that you would go out. It will be something where you would instill and deploy your policy. It could be the central intelligence for the control plane for the overall WAN. But there's one other feature that we're going to talk about we think is very critical, which is it's going to be a time source. It's going to sync the WAN, if you will, with the devices that are really important for implementing the SD-WAN overall. And the time is going to be very important because it's going to be very helpful for us when we have to go through and track some of the things like delay and jitter. So that's part number one. We have this control. Next thing we're going to do, what is it going to be working with? Well, there's going to be the end nodes. Now, these are typically going to be physical, cloud-based, or virtual appliances. And we're finding, and I didn't talk about it on the previous slide, but another emerging trend that we see quite a bit of within the customer space is the inclusion of cloud as a part of their WAN infrastructure. Either it's there today or it's a key part that is being incorporated as things move forward. So being able to extend the WAN, the SD-WAN in this case, to any of these parts of the network or using these types of platforms is critical moving forward. So you're going to need to have these nodes. Now, these nodes in and of themselves are going to have to be able to have the ability to identify when there's a problem across the WAN and react very quickly, going into the blue box that we highlight above. In addition, we're going to have multiple networks involved. So we have here MPLS or internet. Usually we find there's a wide range of networks that can be involved. Usually if they pass IP traffic between the sites, that's going to be fundamental. And so it could be MPLS, internet, LTE, 3G, 4G, basically cellular networks, satellite networks, microwave. Once again, passes IP traffic. That's great, and we can usually leverage that in order to provide the base level of connectivity. The other thing you really do want to have is these multiple networks because you need a choice. If you just have one network, obviously there is a single point of failure. If the network has a problem, or if there's increased latency and you have just one MPLS environment, then obviously there is not too much of a choice or option to try and take corrective action other than working with the service provider to address whatever the problem is. So you want multiple networks that you can then work with and determine which is the best path based upon the current state of the overall WAN. Okay. Beyond that, and what we do is we actually have overlays that we use. So we have this underlay where we've got the MPLS, internet, cellular, whatever type of network, and then what the devices, nodes, actually use to communicate are tunnels. So these are the links. This is where we will logically pass the packets between the different end nodes. Now what we also do, and we highlighted here in green, is there's a lot of tunneling technologies out there, but one of the things that's very important is we want to be able to go through and on every packet that we send over these overlay links, we want to have some very granular information. We timestamp them. This word time comes up again. And since the clock is synced across all these networks, and all these devices, I should say, then we can get very accurate granular measurements, since we're going across with every packet, of how the packet is traversing across the network. So when it arrives, we can very accurately calculate the delay, jitter, and we also have sequence numbers, so we can obviously calculate then loss. That's very important, and it goes back into you need that granular information in order to have that rapid time to recover. The last part that we have is a reporting and analytics platform that's required in order to go through and give you the visibility that you're going to need in order to track. Because once these networks are up and running, usually they're very dynamic. They make decisions on the fly. They can't wait, especially if they're going to maintain SLAs for the applications. And you want to actually have the visibility to go in and do, let's say, root cause analysis to identify problems, and also to use the information to go through and try and build training information to go through and do capacity planning, validation of link integrity and things like that. Maybe you need to go and talk to your service provider because they're not meeting the SLAs based upon some of the data that the network is identifying. And these are the tools that will help you do that. So anyway, these are the components that we put together. Now, what are some of the things that they enable once they're up and running? Well, here we're going to talk about some of the capabilities. So the first one is going to be fast failover. Now, what this basically indicates here is obviously you've got some packets that are flowing across a link that's been established, our conduit, our tunnel. And let's just say we identify that the link that we're actually using is starting to have an impediment. Maybe it doesn't have to be a complete failure. It could be that maybe the delay is increasing up to the point where it's crossing a threshold, and we know that that's going to impact the voice session. Let's use that as the assumption here. Well, what we can do is we can rapidly fail over with the infrastructure we just described on the previous slide to the second link. But we can do this. Usually we can identify there's a problem and transfer over within 3 packets. And that's very fast. What does that mean? Calls don't get dropped. Sessions remain up and running even when we fail over to maybe a separate link, go from MPLS over to the internet link. So that at the end, that quality of experience we talked about is maintained even though there was an impediment on, let's say, one of the WAN links that would have normally seriously undermined or deterred or made it difficult for that application to continue to run without a problem. The other thing we do, we obviously, if we're going to have, you're never going to be able to guarantee that you don't have any contention for resources, and that's where quality service usually comes in. And we obviously support that. We have multiple queues, and we can go through and service them based upon priorities and policy and things along those lines. But another thing that we also have implemented in this is we have a mechanism to do reservation of bandwidth. And this is another thing that's very important to maintaining the SLA. So for an example, we highlight here, a new session is being brought up, and the sending device will go through and request from the destination device, I want to turn up this session. I got a new call that's being established. Can I send the packet through? And then that node will respond. And let's say it's a positive, sure. And then the traffic will flow through on the underlying links. Now, there may be situations where there is no capacity on the other end, and the response back might be, I can't handle it right now. We need to do something else. We need to pause that traffic. And then we could take the appropriate action. What this allows us to do is make sure that, I like to use an analogy of it's almost like a ground hold on an airplane. It's cheaper, more efficient to have the airplane, let's say, wait on the ground at the source airport than have it take off and then circle, wasting fuel, if the destination airport cannot accommodate it because there's no landing slots. So we're doing the same thing here. It's very expensive to send the traffic over the WAN link just to have it not being able to be supported. But the other thing the reservation does is if you do have a reservation, we guarantee you some buffer. So if you're in, we then can ensure that when your traffic comes over, we do have some space to ensure that that traffic does get processed. So it's a very nice touch. And once again, a lot of solutions that are maybe out there, they may not do this, and this is an important one for maintaining SLAs. The next thing we're going to talk about is packet duplication. And what we fundamentally do here, and the name's pretty, it's very direct and it's self-explanatory. We send the packets. Let's say you have multiple links. We send the packets down each one of those links. And the first one to reach the destination wins. So by definition, that's going to be the best performing link that will send the traffic through. And for the remaining packets, the duplicates that arrive late, those get discarded. So the nice thing about this, there's a pro and con with this approach, that we find that for mission-critical applications, you'll basically send double the amount of traffic, in this case, which wastes bandwidth, but you're guaranteeing that those packets will arrive. Because what are the odds that both packets will get lost or discarded if they're traversing 2 separate networks? It's not very high. And so, once again, if you're in that mission-critical type of application space, then this is a technique you may also wish to leverage. And lastly, link aggregation. This is really great for helping with applications that require a fair amount of bandwidth. So some of the bulk transfers or file transfers is an example, where we can actually analyze all of the links that we have available to us and then aggregate it up so that a single application or flow will take advantage and use all of that available bandwidth to send traffic, and we can then, as we see here, we're kind of striking the packets across both of the links. Now, the nice thing is we also have, looking at our quality of service, that let's say, we're using the bandwidth for these transfers, and then we have a higher priority session come in, let's say a voice call. We can then take and throttle down some of the bandwidth that we were allocating to the bulk transfer, because normally for most customers that will not be as high a priority as the voice call, and feed that into then make that available to the voice call so it can get processed, and then still remain and give the bulk transfer a fair amount of bandwidth for it to continue. So we do have the intelligence to go through and adjust based upon the real-time state of the network and what types of flows we're seeing coming in from various applications. So with this, I'm now going to stop, and I'm going to hand it over to Alex, and he's going to walk you through a demo of some of the things that we've just discussed. So Alex, over to you.
Thank you, Neil. Give me 1 second. Let me share my screen. Share. Okay. Okay, so I'm just going to do a very simple demonstration of Talari in action. And what we have is a simple lab setup. I've got 2 sites connected by various forms of WAN connectivity. At my data center side, I've got a big Metro E fiber and an MPLS connection. And then down at my branch, at my client, I've got a number of different broadbands and an MPLS connection. And then we're running various types of traffic through this. We've got some bulk traffic, FTP. We've got some SSL going on, some HTTPS, and then a number of simulated voice calls here. One of the voice calls actually goes through the Talari overlay, through the Talari and is being protected. And we have some comparison voice flows going alongside the Talari overlay just on the underlay network, so we can compare the effects of network quality. And essentially what we're doing is we're aggregating all of these WAN links together so that we can see the WAN path characteristics and react to network impairment. So you see the Talari automatically meshes all of the paths that we have available between these 2 locations, and we measure the quality characteristics on a per packet basis, as Neil has previously said. So I'll just switch the screen to the test bed here. So I'm using IX Chariot to generate the traffic and also give me MOS scores and throughput scores for the applications. And you can see in our graphs here, we've got about 22 megabits of FTP. We've got about 5 megabits of combined HTTPS traffic. And then we have 4 different voice flows here, and we're getting a MOS score pretty much perfect for all of the voice flows here. They're actually overlaying on top of each other here on the graph to the right-hand side. But we're getting basically around about a 4.3 average MOS score across all of our calls, right? And then in the middle here, we have all of the Talari paths, and this view shows me the path stats every 5 seconds. So it's showing me the bandwidth across each path. It's showing me the current measured latency in that direction across the path, and then whether we're seeing any jitter or any packet loss. And you can see that we're between the data center, what we call here the NCN, and the client side, we're sending traffic pretty much in that direction, and it's distributing the traffic across all the paths here. You'll also notice that we're mapping to not only the MPLS path, but to 2 different MPLS queues as well. So I'm able to overlay specifically on top of my quads queues in my private WAN, so that I can still take advantage of the benefits of cloud-based quads here. So I have an EF queue and I have a best effort queue. And I'm going to just do one very, very simple test. I'm actually going to have the world's worst day as a network engineer. I'm actually going to make all of my paths, all of my WAN links highly unstable randomly all at the same time. So this is kind of an unusual situation, but it really does kind of highlight the true value of Talari. Yeah, I can fail WAN links over and applications will move and will recover, but everybody can do that. So what I'm going to do is I'm going to make all of my networks highly unstable. I'm going to induce between 1 and 10% packet loss on all of my WAN links all at the same time. Now what we'll see is very quickly, we'll start to see the Talari will start to show that we're seeing loss across all of these paths randomly, and these things will go up and down. But more importantly, I can look at my graphs here and see that, I'm getting a highly unstable voice calls on the underlay here, right? So you'll notice that all of these lines are starting to vary. My MOS scores are starting to go to hell in a handbag. I'm having to give up bandwidth for my FTP. Doesn't fail, but I have less good bandwidth all at the same time. So I'm compromising my throughput for my lower important applications to ensure that my more important applications, my interactive traffic here and my voice traffic is getting through. Now, if I actually uncheck the underlay voice calls here, we'll see that even though they're all basically varying greatly, if I just take them off the graph here, so you'll actually see that the voice call going through the Tulare is generally unaffected. Now, we're not completely infallible. If all of my paths go lossy all at the same time, obviously Tulare, anything's going to be affected. But you'll notice that the drop-off for the Tulare here is from 4.3 momentarily down to about 3.5. But generally speaking, my voice call is still working effectively and working very well. If I load the underlay ones back in, you'll see that comparatively, my voice call going across the internet or going across my MPLS here is highly effective. So even though my network is behaving extremely poorly, extremely randomly here, the important applications, my real-time flows are still getting through. I'm having to sacrifice and compromise on my bulk applications because I have less good bandwidth. But generally, I'm still preserving all of my applications through the network, and they're still working effectively. If I clear out the network conditions here, we'll just go back to a zero loss and jitter. We'll notice that everything will, as soon as the network becomes good again, everything will start to normalize here. We'll start to see my FTP go back up to full capacity and be able to utilize all of the bandwidth. So two things that are really happening here. One is we're detecting network impairment on a per packet basis in a sub-second time frame so that we can react very, very quickly and very, very aggressively to preserve our applications through the network. The second thing here is we're doing complete and closed loop end-to-end bandwidth control, so I don't try to send traffic to a link that's either congested or in poor shape in terms of network quality. And also I'm doing advanced things like packet duplication for my voice, so I'm actually sending my application down two different paths simultaneously and then using whichever packet gets to the other side first and suppressing the duplication. So we have a very, very high level of resiliency and reliability built into the Tulare solution to take care of extreme situations of network impairment. Like I said, this is a highly unusual situation, but it really does talk to the advanced capabilities of what Tulare does and how well we can protect application traffic through the network. And with that, I'll introduce Joel. Joel actually works for a company called Bremer Bank, and they've been a customer of Tulare's for many years. And Joel's going to kind of talk to his real world experience and how he sees how Tulare has benefited him. I will just go back to stop sharing my screen. How do I do that? 1 second. Okay, we should be back on the slides now. Over to you, Joel.
Thank you, Alex. Yeah, as Alex said and Neil said, I'm a network engineer for a bank called Bremer Bank. We're in the upper Midwest, and there's some of our company stats you can see on the slide there. What I want to do today is talk about how Bremer became a Tulare customer and how we got there. When I started at Bremer Bank, they were going through kind of what they call a WAN cleanup project. We had about 100 branches that were on various different connection methods providers, some MPLS, some point-to-point, different types of connections. We were getting those all down to one MPLS network, and so that was a great start to consolidate all that together. Mostly just T1s or multiple T1s, some were bigger branches, but very basic. And we started with just one MPLS network, and we brought in a second MPLS network that was kind of pseudo MPLS, with another provider, and it was very expensive, and it didn't really work all that great, to be honest with you. When we'd flip over, there was major routing problems, outages, and it was really not worth the money. We use a lot of VoIP over our network, and that was a very critical piece for us along with our banking apps. And so we kind of made the decision we want to do more. We want all our branches to have backups, not just the top ones. So we decided we were going to build our own DMVPN, because that's the kind of people we're doing, and we started ordering Comcast links that were inexpensive and 50 meg, and that was great. But management came to us and said, hey, we're ordering these like 50 meg links to go with our T1s. Can we use this bandwidth? We said, well, not really. I mean, MPLS is our primary, and we want to kind of stay on that because it has quality of service and all these other things. They said, well, if we're paying for it, we want to use it. We want to use both. And so that's when actually at the same time about Tulare called. And we started looking at the Tulare solution. And what Tulare was proposing was exactly what Bremer was asking for. We wanted to get rid of the high-cost MPLS, and we wanted the active links. We wanted to use everything we had at the same time, and we wanted to have that failover be seamless. So we did a lot of whiteboarding with Tulare. They sent Alex up here personally to work out a solution with us. We decided to go ahead and do a trial with Tulare. And we looked at some other competitors, but none could really match the seamless failover that Tulare was offering. So we set up a small lab pilot network, and Tulare sent an engineer from the factory up here to actually help us set it up. And we installed all the gear. We brought in a test T1 and a test DSL connection into our lab, and we actually put the Tulare right on that. And we set everything up, and we started a phone call, and we put it on speakerphone, and then we went over and yanked out the T1, and we could not tell that phone call, there was any blip on that phone call at all. And I showed that to my boss, and he actually ran down the hall and got his boss and brought him in and showed up the demo. And people were just blown away by that. That you could literally be on a phone call talking to somebody, pull out your T1, and there was no noticeable difference at all. So that was a huge thing for us. We also played around. We have a WAN simulator here. We played around with introducing a latency and loss, just like Alex did in the demo, into our network, and we could watch Tulare react and move the packets around. It was very impressive. So once we proved it out in the lab, we started with some pilot sites. So we picked like 5 of our sites, and we just took one night, and we rolled 5 of those there, and everything went really well. The branches, they had more bandwidth, they had backup connectivity, and there was really no, by inserting that Tulare into the network, they really didn't know there was any difference. So in the next day when they came in, the Tulare was there. They had more backup and more bandwidth and backup, and really didn't know that anything had changed. So that was really good results. So we decided to go ahead with the Tulare solution. We started rolling out slowly to more and more branches. Tulare helped us with the first few, and then it became very cookie cutter after that. There's actually a duplication option in the Tulare configuration editor that we use. So once we had our sites down, we just hit duplicate, change the IP addresses, and hit save, and that would just basically build out new sites for us. And then we just drive to the site, we drop the Tulare in, load the configuration, and off we went. It was very easy to install. The thing that really helped us when we did this was at the same time on our branches, we also changed the IP scheme we were using. So we had branches with they had like 10 people in them that had like Class B subnets assigned to them. So we cleaned a lot of that up, and we got everybody on the same IP scheme. So when we did that duplication, we could just roll through very quickly and just change like the third octet. Tulare offers a very good QoS implementation. It's very robust. We were able to put all of our applications that we need in there and get those prioritized correctly. And that was key for us because we have a lot of major banking apps that we need to put at the top of the list, along with voice. The other thing we found very interesting with Tulare was how much data we got back on our providers. I refer to Tulare as like the black light because it showed us so many things that were wrong on our WAN with our MPLS provider and our Comcast circuits, things that we've never known were there before. Our MPLS provider had QoS configured incorrectly on their network, and we were able to detect that through packet loss and latency issues from the Tulare reports. And so we actually found things that we didn't know were there before once we got Tulare in and once we got all that data back. So far, things have gone really well. It's been very hands-off. It basically, the system kind of takes care of itself. All we really had to done is go ahead and do our software upgrades and things like that. The only thing we've really had to go back and do was do our kind of our bandwidth tuning at our sites. As we rolled it out, we kept things very flat, and every branch got the same percentage of bandwidth allocation. And we hit a certain point where we had to go back and start tuning that because we don't have all branches that are the same size. We have some branches with 2 people and some branches with 100 people. So it didn't make sense to have the shares be equal. So Tulare helps us tune those shares so we could put certain branches in buckets and say this is a 50-person branch, this is a 20-person branch, and give them more bandwidth because they're consistently asking for that bandwidth. But since then, it's been very hands-off. The support and maintenance has been good. I can just email Tulare, and within 5 to 10 minutes, my ticket has been picked up, and somebody's already calling me to start telling me with the problem. And there haven't been a lot of problems. It's but the boxes have been pretty reliable. Everyone's been really easy to work with. Another thing Tulare does really well is listen to feedback. I've never had a company that is so engaged with the customer. They're always talking to us, asking what features we'd like, what's working for us, what's not working for us, and then in turn they're also responding and meeting those needs that we have. So if we say there's a certain feature we want, they will go to the length to put that feature in, even if it's just for us. So they're really listening to customers, and they're really tailoring the product for what the customers want. And that's my Tulare story. And if you have any questions for me about Bremer and how we use Tulare, please ask a question in the chat window. And Neil, back to you.
Okay. Well, thank you, Joel. And we do actually have a question for you, and we'll get to those here in a minute. We're just going to wrap up. So right now, we'll go through a quick summary here. So as we discussed earlier, there's a lot of change taking place within the WAN. There's a lot of pressure on IT to go through and address the financial and quality of experience requirements and constraints that they're being expected to support. We think a new WAN architecture is required, and we think Tulare has a really good solution to help you achieve and meet these challenges. So we give you a link there to go through and visit to find out more information. So it's pretty straightforward, tulare.com. Now what we'll do is we'll go into the Q&A, and we've got a handful of questions. We'll go through, and so Alex, we've got one out there. Let's see. It's going to say, which of these features work with Internet SaaS applications where there's not a Tulare appliance at the other end? So comments there, Alex?
Yeah, great question. So obviously the premise of the Tulare solution is it's bookended, right? You have either a physical or a virtual appliance on both ends of the conversation so that you can use those endpoints to measure the quality between them, all right, and then react to that quality. Now, when we start thinking about SaaS applications, obviously you might not have the ability to deploy, a physical appliance or a virtual appliance out where the SaaS is located. And generally speaking, that kind of makes SD-WAN solutions a little difficult to implement. So there's a couple of things we do or can do to kind of counter that. And I think it's an important trend because we are seeing that shift, towards SaaS-based applications. So one thing we can do is if we're sending traffic out to the internet and we have two alternative paths, we can use the quality characteristics of the overlay to get a sense of, which WAN path we should send the packets to. So I can load balance traffic to an internet path outside of the Tulare tunnel, and I can use the tunnel quality to kind of assess, which path is better at any one point in time. Now, that's flow-based. I can't distribute a flow across two paths doing that, and obviously when the packets have left, I can't react to any network change very quickly, right? So the other alternative, which seems to be a bit more of an emerging trend, is using a cloud-based appliance. So we have packaged the Tulare appliances to fit into things like AWS, or Azure, or even just be a virtual appliance in pretty much anybody's hosting space. And what that allows you to do is you can move that endpoint out very close to where the SaaS applications are hosted, and you're actually then back to your full capabilities of your SD-WAN solution by doing that. Now, there is still a small piece of unoptimized, connectivity network there, but generally speaking, that's inside the data center, and it's pretty well protected and pretty reliable. So, and if you think about where these applications are, they generally sort of coalesce around the same geographic footprint, right? Ashburn, Virginia, Silicon Valley, Seattle for those kind of applications. So we can typically get a virtual appliance or a cloud appliance very close to the actual hosted app.
Very good. We have another question that's come in. It's, does the solution require hardware kind of be implemented on x86 platforms as software? So I'll take that one. And the straight answer on that one is we obviously have dedicated hardware appliances, and you can. So we support run it on x86. So we support Hyper-V and ESX. So we have OVFs as well. So if you want to download a virtual appliance and put it on your hypervised platform, we definitely support that. And we also support Azure, and we have AMIs for Amazon. So for cloud platforms, we obviously have virtual appliances and easy to consume options for those folks as well. So, and those do not require dedicated Tulare hardware. Generic x86 for the hypervisor versions are just fine. So we have a question also coming in for you, Joel. It was, what distinguishing features ended up being the key of why you chose Tulare?
Yeah, great question. We did look at a number of other providers. One was Cisco ION, because we are a big Cisco shop, so we felt very pressured to look at them. And Cisco ION just was not there, and it's still traditional, sending lines of code to 100 different routers. But the great thing about Tulare is that everything is managed from a central point. So no matter how many boxes I have, there's one place to do all the configuration, and there's one place to do all the software upgrades. And I don't have to jump to 100 different routers and make code changes. I can do it all from one place. So that was a big selling point for us over IWAN. We looked at some other providers that were Tulare-like, and they just didn't have the seamless failover that Tulare had. So I would say the two features that made us choose Tulare were the software-defined style management and the seamless failover.
Okay, excellent. We have an additional question out there. Do we have any case studies where the customer's gone purely with internet and eliminated MPLS? And I know the answer to that is a definite yes. So Alex, do you maybe want to walk through any or add any color to that, any of the internet only or customers that we have?
No, absolutely. We're somewhat agnostic to what the underlay connectivity is because we're measuring the empirical quality across each of those paths with every packet that's being sent. So we have several customers that use internet-only connectivity. The key there is having enough path diversity so that your network quality doesn't correlate, right? So where you can get something from Verizon as a broadband circuit and something from Comcast, you get great underlay diversity, and you can build a very resilient, SD-WAN overlay on top of that with Tulare. So yeah, we have lots of customers doing that. There's obvious reasons why you do that, and it's economic, right? But yeah, no issues with that at all.
Okay. And we have one maybe a little bit technical here, but that's cool. We want Cisco requires CDP. Do these boxes support CDP?
So, no, we don't support Cisco Discovery Protocol. I'm not sure in what context we would need to. So, no, that's not something that's built in today.
In fact, we would basically pass that through, depending on how we're configured, so that we would not terminate or participate in it as a part of any exchange. Yep. Okay. So let's see. I'm trying to look through here, and maybe we catch up with one more question. Here's one, Alex. What happens if you lose the controller? So the central control point. What's our HA story? Any color or flavor you want to add to that one?
I'm sorry. Can you say that again? You cut out.
The question is, I'm sorry about that. What happens if you lose the central controller? So what's basically our HA or how does the system work? Yeah,
so the controller can be physically backed up locally as an HA pair. We can also do what we call a geo-diverse deployment, where you can designate another appliance in the network, virtual or physical, to be a backup controller. But if we lose all controllers, for example, the network will still work. So clients can still talk to each other. They can still make their quality measurements, and they remain functional. So there's a number of different ways to protect against controller failure.
Okay, well, and we've got time for two more questions. And so the next one we're going to take is, what's the largest call center size that uses a Talari system? We have over 600 agents at a single site. I'll make a comment and then I'll pass it over to you, Alex. But we actually have some of the largest call center customers, some of the top 2 or 3 in the world, that are using our technology, especially to extend to overseas locations. In fact, at ONS, we actually had Teleperformance, this is one of them, who actually came out in public and talked about their deployment and their success using us. So you can look them up on the web, and they are based out of Paris, but they're a worldwide company, and they're a very major contact center outsource firm, and they use us in many of their international locations. But Alex, any other color that you'd like to add to call centers?
Yeah, I mean, the largest physical appliance we have is the 5200. That has 10 gig optical interfaces on it and will sustain, I think, 5 gigs full duplex. If not right now, but in the next release, it'll do more than that. So yeah, we have a very large appliance that will do up to 5 gigs of sustained traffic, right? So we also have some virtuals as well. We haven't really scaled the virtuals up beyond several hundred megabits, but there's no reason why we couldn't do that as well. Okay, so you know what? We're going to have this. We'll make this one the last one. Any MTU issues with timestamp serial numbers in each packet? So great question. Obviously, we have to. We're adding overhead, right, in terms of a tunnel, and as you say, we do have to add what we call a TRP shim, a Talari Reliability Protocol shim, which adds the sequencing and the control and all the data going backwards and forwards. So we do size the tunnel MTU size down, and we automatically calculate that based on the underlay MTU size. Now we have our own fragmentation and reassembly solution, so that anytime we have to cut a packet up to put it in the tunnel, we actually reassemble it on the receiving side before we deliver it back to the network. So we don't pass fragmentation downstream, and that's how we kind of counter and compensate for the diminishing MTU size we have in the tunnel. Okay. Thank you, Alex. And actually, with that, we will wrap the webinar. And I want to thank all of you for joining us. We appreciate your time and interest. And we look forward. We are actually going to be coming back, usually on a quarterly basis, to have incremental updates for you. And so be on the lookout. If you enjoyed this webinar, we'll have one coming up in a couple of months. So you're more than welcome to join us again. Thank you, and have a good day. Take care.